Hi everyone, this is S. Venkatesh. I'm from CSCD and today we're going to discuss a timestamp based concurrency control. And let's get into the topic and timestamp ordering protocol. The main idea for this protocol is to order the transaction based on their timestamps. A schedule in which the transactions participate is then serializable and the only equivalent serial schedule permitted as the transactions in the order of their timestamp values. An algorithm must ensure that for each item accessed by conflicting operations in the schedule, the order in which the item is accessed does not violate the ordering. To ensure this, we use two timestamp values relating to each database item X. WTS, write timestamp of X, is the largest timestamp of any transaction that executed write of X successfully. And RTS of X means read. Read timestamp of X is the largest timestamp of any transaction that executed read of X successfully. And let's by coming to basic timestamp ordering, every transaction is issued a timestamp based on when it enters the system. Suppose if an old transaction TI has a timestamp of TS of TI, a new transaction TJ is assigned timestamp TS of TJ such that TS for TI is less than TS of TJ. That means first the transaction TI is as create as coming to the uh, um, and the timestamp of TI must and should be less than the timestamp of TJ. And whenever some transaction T tries to issue a R item of X or a W item of X, the basic time ordering algorithm compares the timestamp of T with RTS of X and WTS of X to ensure that the timestamp order is not violated. This describes the basic time ordering protocol in the following two cases. First, case one, considering case one, when a transaction T issues a uh, right item of X operation, check the following conditions. If RTS of X greater than TS of T, timestamp of T, and if WTS of X greater than TS of T, then abort and rollback T transaction and reject the operation else. If the condition is not possible, then we gonna see the other possible, that is execute W item of X, operation of T, and set WTS of X to timestamp of transaction. Uh, by seeing this, the second case, whenever a transaction T issues a R item of X operation, check the following conditions. First, if WTS of X greater than TS of T, then abort and reject T and reject the operation else. If WTS of X less than or equal to TS of T, then execute the R item of X operation of T and set RTS of X to the larger of TS of T transaction and current RTS of X. One drawback of the basic time outing protocol is that cascading rollback is still possible. Suppose we have a transaction T1 and T2 as if state value written by T1. If T1 is aborted and resubmitted to the system, then TS must also be aborted and rollback. So the problem of cascading abort still prevails. And the advantages of the timestamp based concurrency we control is a high concurrency. Timestamp based concurrency control allows for a high degree of concurrency by ensuring that the transactions do not interfere with each other. Efficient. The technique is efficient and scalable as it does not require locking and can handle a large number of transactions. No deadlocks. Since there are no locks involved, there is no possibility of deadlocks occurring. Improved performance. By allowing a transaction to execute concurrently, the overall performance of the data system can be improved. And by in case of disadvantages, there are mainly comes into the scenario as limited granularity timestamp ordering, timestamp synchronization, timestamp allocation. First, limited granularity. The granularity of timestamp-based concurrency control is limited to the precision of the timestamp. This can lead to situations where transactions are unnecessarily blocked, even if they do not conflict with each other. And the second one is timestamp ordering. In order to ensure that transactions are executed in the correct order, the timestamps need to be carefully managed. If not managed properly, it can lead to inconsistencies in the database. The third one is timestamp synchronization. Timestamp-based concurrency control requires that all transactions have synchronized clocks. If the clocks are not synchronized, it can lead to incorrect ordering of transactions. And the fourth one, timestamp allocation. Allocating unique timestamps for each transaction can be challenging, especially in distributed systems where transactions may be initiated at different locations. And thank you guys.